All right, question 11. This is a geometric distribution. Suppose we interview randomly selected women who are or have been pregnant until we find someone who has experienced morning sickness. Remember our last question, 70% of women experienced morning sickness, so we're going to use that same probability. How many women do we expect to interview in order to find our first who has experienced morning sickness? All right, so that mean expected is, there's a formula for that. If you look on your formula sheet, it's 1 divided by the probability. We didn't go over that, but you just do 1 divided by 0.7, and you get about 1.43. Same with standard deviation. There's a formula for that for geometric. You just do the square root of 1 minus the probability. So 1 minus 0.7 divided by the probability, 0.7, and you get about 0.782. And geometric distributions are actually always skewed right. So we'll find that out a little bit more when we investigate those in sampling distributions. So just going to gloss over that. Don't worry about that for your exam. For the next two, find the probability we interview our first woman with morning sickness on our 5th interview. So there's a couple ways to do it. Geometric distribution, second vars, geometric PDF, we want to know an exact number. So 0.7, 5th interview. Then you get about 0.00567. That interpretation is 0.3 to the 4th power times 0.7 to the 1st power. So that's what that is. And if you look at the formula sheet here, again, it's basically how that works is all the knots until you get the one you want. So here's the work for it. 0.3 to the 4th power times 0.7. Now with the next one, find probability we interview our first woman with morning sickness by the 5th. That means 5th, 4th, 3rd, 2nd, 1st. So we got a lot that we can add up. So you want to do geometric CDF because you're combining those. And that's going to look like this. Geometric CDF, 0.7, X value is 5, but it's going to include 5 and everything below it. So what that is 0.7 plus 0.3 to the 1st power times 0.7 plus 0.3 to the 2nd power times 0.7 plus 0.3 to the 3rd power times 0.7. And then finally, plus 0.3 to the 4th power times 0.7. And that's just all of them added together and to get that total combined 0.99757. All right, that's all.